Hey guys, in last video, we see the GNU assembler S is available on the Ubuntu. Before we use the guess to translate our very first program into machine code, we have a look at two concepts. The process that translating an assembler file to machine code is called assembly. The generated file is called object file. Let's go back to terminal to see how to use guess. I already logged into Ubuntu. Remember, we have created this exercise folder in video 1. We open this folder, we can see a file, the first.s in it. That's our very first program in assembly language. Now we right click inside of this folder, click open terminal, and then we can use S to translate this source file to an object file. Just tell S the file name is first.s. We see a warning. It says end of a file, not at end of a line, new line inserted. The reason for this is Windows and Linux or Unix-like system are dealing with the text file in a different way. We can ignore this for now, just create a new file. Touch, say second.s. Then we open this first.s. Select all. Ctrl C to copy. Close. And paste all of this here. Close the new file. Save. We retry this command for second.s. We can see no warning this time. We can try something to remove that 8.out. You see, if we don't give the other options, the default name 8.out will be used. .s. Then we can rename this. Then we use the s first. .s again. If we want to create if we use the option -o first.o, which means we are telling the assembler to use first.o as the generated file name. Great. We see the first.o is generated, and that's the object file. Great. We have just created an object file first.o. Now we would like to see what is inside of the object file. A program hexadecimal can be used to view the content of the object file. We also will get a concrete understanding on what is a bit, what is a byte. What does binary and hexadecimal number look like? Let's try hexadecimal. Then we use hexadecimal first.o to see what happens. We drag into the very beginning of the output. We can see there are about 1, 2, 3, 4, 8 columns in the central. I mean, the first one 7, 5, and the last one is 4 zeros. The 7, 5 here is in hexadecimal, which means each of these number digit, I mean all the letter in a hexadecimal equals 4 binary bits. So each column of this actually has 2 bytes, and so the first line has at time 2 equals 16 bytes. And then if we see the second line, the first number is 10. The 10 here is still in hexadecimal. So the 10 here actually equals to 16 in decimal. So which means the default output of the program XXD is in hexadecimal. Now we try give this program option -b and first.o. We drag to the very beginning of the output again. We see this time there are only 1, 2, 3, 4, 5, 6 columns in between. The first column, see there are 8 numbers, and each of the number are either 1 or 0, so it's a combination of zeros and ones. Each of these digit number 0 or 1, each of these 1 or 0 called a bit, and there are 8 bits in each column, and for every 8 bits called a byte. So the first line has 6 bytes in total, and the second line we can see the first one is byte 6. That's because it starts counting from 0. So the first column is byte 0, and then the second column byte 1, byte 2, byte 3, byte 4, byte 5. So the first byte of the second line is byte 6. Now we have a very concrete understanding of what does the object file contain. We have already learned that the process that translating an assembly source file to object file is called assembly. Can we do it the other way? To translate an object file to the human readable text file? Yes, then the process is called disassembly. The program object dump can do this. Let's try it now. We use dump. Give it the two option -m i8086. We will explain this option later. Now the output displays on the screen. We can see from this line starting from the 0 on the right side, it's the assembly code. We open the original source file to compare these two. We can see the first line of the original file is move26, and this generated one is 0x1i. We have learned that any number start with 0x means it's in hexadecimal. So 1i here means 1 is for 16 in decimal, and a is 10, so 10 plus 16, that's 26. That's exactly the number in the source file. And similarly, until the line loop jump 11. So 11 here means the series number of the byte. As we can see, the first line there are 3 bytes, and that 3 bytes is the machine code of the corresponding assembly language. The first line, I mean. So, and then the second line is another 3 bytes. We understand that every 2 numbers here actually that's hexadecimal. Now we just input the object dump. Press enter, it will list a help to explain the options. We can see from the bottom the -t here means display the contents of the symbol tables, which means the symbol table is one component of the object file. And then we see another one, the dash R, displays the relocation entries in the file, which means the relocation information is another part of the generated object file. And then to the top, we see there are something like display different kind of header information. The dash D, we already used this option. It means to display the contents of executable sections. Now we put these three options on to see the output, the dash T, R, and F. This dash F means to display the contents of the overall file header. T. Now we drag this to the top. We can see the very top part. That's the header information, and then comes the symbol table information. And then we drag to the bottom. We can see previously there's no align, and now gives a reference .txt plus 13. 13 we can see here, that's exactly where the message location goes. By now we understand inside of the object file there's not only the code or data, but also there are some other information like the relocation information, the symbol table, and the header information. We come back to see why we use the option -mi at 086. Firstly, we need to go through a concept, architecture in computer science. In computer engineering, computer architecture is a set of rules and methods that describe the functionality, organization, and implementation of computer systems. Some definitions of architecture define it as describing the capabilities and the programming model of a computer, but not a particular implementation. Do you understand this? At least I don't think I understand this very well. Let's think about it in another way. Imagine any computer that have a specific set of, say, 500 instructions. That's all the instructions that the CPU of any of this kind of computer can recognize. We say this specific set of the instructions defines the architecture of the computer. So another different set of instructions similarly defines a different architecture. That's much easier, isn't it? Now let's have a look at the x86 family. All the personal computers in nowadays use the x86 architecture. It contains from the 16-bit, 32-bit to 64-bit version. The most recently 64-bit version can be called either AMD 64, Intel 64, x86-64, x86 underscore 64, lowercase AMD 64, or x64. All of these, that's the same thing. When we say i386 or i8-32, that's exactly the same thing, the 32-bit version of x86. The one we designated as the option of the program object dump is 8086, which is the 16-bit version. One very important feature of the x86 family is it is backward compatible, which means, for example, you don't need to do anything to run a 32-bit version program on a 64-bit machine. That's very nice, isn't it? Lastly, we need to know when we see the architecture i8-64, that's not a part of the 86 family. Now we know the 8086 is the 16-bit version of the x86 architecture. At a later stage, we will explain why we choose this 16-bit version as the option. See you in the next video.